right, welcome back, and this is, well, let's take a look at what this is. So, did I open that? Yeah, okay. Now we're in number 12 here, and just to kind of look at that, here we are, open source, and of course we've got number 12. Now, again, I have not uploaded 13 because, well, it's kind of a surprise, but you know what, screw it, I'll tell you. I'm working on a font system, font of my own, hand coding it. So that's future, and of course also kernel loading and other aspects I'm going to be adding to this GitHub. So it may seem like I'm not doing anything for a while, but trust me, I'm working on it. There's a lot more I have to share with you. So, all right. So in this particular one, we're going to read what is inside this text file. Now, I'm going to open it, and this is what's in the text file. So what we're going to do is we're going to read it as a HEX interface, basically. We're going to see what those are in HEX. And that means I had to actually create what's called a libs file. Now let's go ahead and open this up and close. There we go. And we'll go ahead and close these. No, don't save anything. And that one too. Come on, work with me here. All right, so in here, I've got this all set up and ready to go. Now, what this does is it takes whatever integer that you throw at it, and we tell it, okay, are we going to return a decimal or a hex? So it takes whatever we input into it, and it returns one or the other. And it puts it into this buffer. And the buffer is what we'll be able to read. All right, so that takes care of that aspect of it. And now, I don't believe I've changed anything here. And I think it's, I really need to work with this. That really drives me crazy. All right, so yeah, I don't think I've actually changed anything. I think everything is pretty much standard. Let's scroll down. Really? Sometimes the mouse is just not going to play nice. Okay, so yeah, we have the EFI, we got the read. Oh, okay, so this is the aspect we're going to be dealing with, is reading. And we're going to read it into a buffer that we're going to assign it. Okay, now we're not talking about the same buffer as this. This is a different buffer to be able to display onto the screen, because we have to be able to convert from an integer to a hex code, all right, so that we can input it into a string. Yeah, so let's go ahead and take care of this, and we can read and write, and again, that's where that permissions of read-only comes in, and we will discuss that later. So we have everything here. Nothing here is changed. Oh, by the way, if this is missing, that's actually, come to think of it, I probably should move this into the CLibs. That's probably where I should be moving that to. I'll probably do that on the next GitHub repo, and well, I'll fix that later. Let's see. Everything should be the same. Ow, sorry about that. We've got the initialize, we've got the open, and we've got the close. Yeah, so nothing has changed. Now, again, the permissions of read-only, that's where that comes in. So nothing has really changed here. I just wanted to make sure that, verify that. So with that, now all we have is this to look at. And yeah, this is where we open the file system. We create a buffer handle, or in this case, an OS buffer handle. You can name it whatever you want. Just make sure that whenever you use this, it matches, you know, all over the place, wherever it's got to go. Okay, so we create the handle here. We load it, and I'm going to stretch that so it's easier to see. We load it here, and you have to have this special void for that to work, and it's a reference and then dereferences and then re-references as a pointer to an actual handle that we can utilize here. It's kind of some trickery, but it works. We're going to set this to, let's see, this is file size here, but I believe that's an actual memory address up here. So they, even though I have them identical, this is hard-coded. We want this to be dynamic in the future, but for now, I left it like this, okay? It's not going to hurt anything. Because we can actually utilize that exact memory address when we go to load our kernel. Right now, we're just loading this text file into that same spot that we would normally load a kernel. Okay, so once we get back the file protocol, if it's not null, then we go ahead and allocate the memory for it so that we can set up this buffer handle with this much memory space. Let's see what else. Yeah. So this is already assigned in memory somewhere. And this is just saying how much space that we're assigning to it. And then here, for file size, we actually have to tell it, okay, when we read this, we have to make sure that we allocate enough space in here. So that's where we assign file size here. Now, I could have set this up above and had file size here and here, but when I tried that, it didn't work. So, yeah, that's why I had to do it this way. Okay, so once it reads the file and loads it here by reading it into the buffer, assigning it to here, okay, then we close the file itself. We don't need access to the file anymore. That means that we have this to play with. Now, this is our new file handle. We can access the file from here. And then I gave a little information here about the hex code and what you can do here. We take the file handle. We don't want to change anything with this file handle. So what we do is we create a new handle. All right, but in this case, it's an 8-bit handle. We're converting it. So that way we can read this 1 byte at a time out of memory. And then this just loops through that memory, and I'm telling it, okay, loop through it 20 times. In other words, even though we have this much RAM, I mean, that's what, I think it's a meg of RAM, I think. If I recall correctly, it's a meg of RAM. But we're only taking 20 bytes of that. Okay? So we loop through it, and what we're doing is that ITOA, that's over here, we pull each character, 1 byte character. Remember, 8 bits is 1 byte. We pull each character from this, we create the buffer, and then add it into, by converting it and printing it. And what this does here is this allows 2 bytes of memory, because for every byte that you're going to print to the screen, since we are dealing with Unicode, we need 2 bytes, which is 16 bits. All right? So that's how we convert this by assigning it an array of 2. So this takes the info from this spot here, takes the character, and it assigns it and puts it into the buffer here by the use of this function here. Hopefully this is making sense. Then we print it to the screen, whatever that S is. Then we print a space in between it, and then we advanced this and loop around, and we do this 20 times. And yeah, that's how that works. Now, how does this works is because we are taking this as a handle and we're advancing our pointer to this. So that is where this comes in handy. When we created this as a pointer right here. Well, technically we created this as a pointer. And it's a pointer to a pointer. You know. And then we print, and that is pretty much that. So there's really not much else to this. Now, how this works, though, is when we assigned it hex here, you can actually assign it decimal as well. But I've defined both of them here. And this will convert based off of, depending on which one you do here. Let's see what else. I guess let's just look at it and see how this works. So compile. Now, if you have any questions, please leave it in the comment or come to my Discord and you can ask live. You know, I'll try to answer when I can. What am I doing here? You might see the screen. Oh, there we go. Okay. EFI tuts. Yep. Open. Next. Mount entire image. There. And there we go. Mount. Wait for it. There's the file. And voila. Replace. Now, last time we verified that the file was there. This time we're actually reading it. So we're going to go ahead and close that. I'm going to go ahead and open this. Put that here. We'll move that to the side. And we'll go ahead and close that. Open this. And the tuts, everything's good there. Okay. Come on, you can do it. There you go. All right. So hit the space bar and voila, we actually have this. And what it's doing is, again, it's converting it to a hex. So what is 54? Well, let's take a look at what this is. So if you were to look this up on an ASCII chart, okay, and you were to actually verify the letter T. So let's find one that has a good reference here. There's one I really like that's in here. Yeah, let's try. Oh, wait. And, ooh, let's try this one. Is that what I'm looking for? Yeah, that might be what I'm looking for. So let's try this one. All right. So the letter T, there it is. So it's 54 in hex. There it is. And if you were to look at it in decimal, it's an 84. All right. So this is a text file. Now, here's the cool part. As you're comparing this, so H, well, let's look at a lowercase h, not a capitalized. That's 48. This would be a 68. So let's take a look at what we have. 68. And as you can see, it goes all the way through all 20 characters. There are 20 characters here. And this spot here is number 21. So yeah, there are actual 20 characters right there. So, and then a period is 2E, which if you were to look at this again, the dot is 2E right there, which, yeah. So hopefully that helps you figure out that this is actually working. And if you change the message, now you can go longer if you want, okay? But the thing is we have it currently set to only look for 20. Just raise that number from 20 to whatever the size of this is. Now, here's something else. I'm going to close all this before I end this video. And if you were to, let's see, go to source, go to number 12, and I have that free hex editor that I love to use, and you were to actually drag this in here, you can actually see this right here. And if you'll notice, the same numbers actually exist. It starts with 54, 68, and ends with 2E, just like what we have. So a hex editor will actually show you this as well. So yeah, our actual hex is working. Now that will come in handy when we want to read spots in memory, because that's basically what we just did. And for debugging and stuff, that's going to really come in handy later. Okay, so I'm babbling enough. I will see you on the next tutorial. I don't know when it'll be because I'm moving. So this is why I've ended this tutorial as tutorial 12. But in the meantime, I will be coding while I'm offline because I don't know if I will be able to get back online for a while. It'd probably be yeah, I don't know when. Anyhow, I'll try to get back to you and see you on next time.